Hello, and very good evening, everyone. Can you hear me?
Yes,
I
better.
can let
Okay. Okay. So today we will learn how to use SPSS in the calculation of correlation and linear correlation and linear regression. So I will not going to take a lot of your time. So today's session will be very quick. So please pay attention. So it will take approximately around 30 minutes or 40 minutes. So please pay attention to every step. It's very easy and straightforward. So I will share the screen of the SPSS software. I will assume that everyone know this software and know the basic of this software. So if you have any question, you can just directly speak up. So as we all know that this software, we have like two options, like we have variable view and we have the data view. So in order to create the column and row, we need to use variable view. Okay, so I will start with entering the data. If you don't have to copy or you cannot, Dr. Isam, I'm late because I was involved in the labs. Okay, we just started actually. Okay, so if you have the data that you can copy and paste, you can just straight away copy and paste. If you don't have, you can just manually enter the data. So in today's session, I will manually enter the data. Okay. So does anyone got any like idea about any data? So I will just randomly type. So for example, we can use like education years and income. Okay, so the first one will be education. The second one will be earning. Okay, so decimal, I will just start with zero decimal and zero decimal. Okay, after I enter these two, sorry, this one spelling mistake. Okay, earning. Okay, and then we go for data view. Here it comes, data view. So we have education and earning. Okay, so now we will just randomly or we will just think about the value because it's just an example. For example, education here we have 1 out of 16 years of education. And if you have, for example, like 7 years of education, how much the approximately income? I know that it's a fake data, but it is just an example, and I will show you how to calculate the linear regression and linear correlation out of this. Okay, assuming that those who like learn only 1 year, and we have those who learn 2 years, and it's okay to duplicate like 3 years, for example, 3 years again, and 4 years, 5 years, 6 years, 7 years, 8 years, 8 years again, 9 years, 10 years, 11 years, 11 again, 12 years, 13 years, 14, 14 again, 15, and 16. Okay, so now we will tell the earning per month for those who educate themselves for only 1 year. They may work in like they sell stuff in Bazar Malam or like work in Starbucks or any restaurant. So still they can earn. Still they can earn a lot of money depending on them. Okay, so we will start either in USD or Malaysian ringgit. So, okay, we will consider Malaysian ringgit here for those who learn or educate for 1 year. So let's put, for example, like 1,750. Okay, for those who, for 2 years, supposed to be more, but we can manipulate the data. Okay, let's put like 1,500 for 3 years. Let's put like 2,000, for example, and another 3 years. Sometimes this guy is like very dumb, so let's put only 900. So we can put any data because it's just an example. For 4 years, let's try like 1,300. For 5 years, let's try like someone very smart, and we put like he can learn or he can earn like 3,000 400. For 6 years, let's put like 2000. Okay, 7 years, let's put like 4000, and so. Okay, for 8 years, and another we have 2 8 years. Let's put like one very smart and one very dumb. So let's put like for this one 4200. Okay, 210, and for the other one only 1800 because it's very dumb. Okay, for the 9 years of education, 9 years of education, let's try to put like 300 or 3800 21, or wherever we can put here like 6,000, which is very high, and here we can put like 4,000. We don't want to make it like straight away for the correlation. Another 11,000, let's try to put like 4,012 and 12 year of education. We try to put like more than 6,000, so it will be 6,200. Okay, for the 13 years of education, let's try to put 7,000 because those guys assuming to have master degree, so it will be 7,100. And for the 14, assuming that he's dumb and is not 7,000, so we stick with 5,200 only. And another 14, assuming that he is very clever and he can earn up to 7,500. And for the 15 years, assuming that he or she can earn up to 8,400. And the last one, 16, supposed to be the highest, but I will stick with only 8,100. Okay, so for now, it's a fake data. It's not a real data, but we have here education per year, 1 out of 16, and we have the earning. Okay, here we have like 20 individual. 20 individual. Okay, we can use SPSS. We can use SPSS to do a scatter plot, to draw the graph scatter plot. We can go for graphs here, graphs, and we can go for scatter dot. You just need to click to this one and use symbol scatter, and click on define, and straight away it will take you to select the y-axis and the x-axis. So the y-axis, we want it to be the learning, because depending on independent value, education will be in the x. So we want the education in the x and the earning will be in the y. Okay, and then you just straight away click OK. And the scatter plot will be like this. Like straight away, as you can see here, here is the earning, like starting from 0 until like 10,000, and here we have the education. So as you all can see, it's like we can see there is a relation or correlation between the x and y. It's a clearly positive correlation. Positive correlation. But how strong the correlation? Yes, it's strong. It will be more than 0.5. So it ranges around like 0.7, 0.8, and so. So here's how we put the scatter plot. Okay. We need the actual R, or the actual value of R. So I don't want, if you want to save this, you can just Control B, click Control B, and save it as a PDF if you were asked to save this scatter plot. Okay, but we don't want to save only this one. We need more. We need more analysis or more data. Okay, so we still have the same education and earning. Now we need to calculate the exact, we need to calculate the linear correlation between the education and earning. So we can just go to analysis, okay, analysis, and select correlation. Which type of correlation? Bivariate. So we just select bivariate. So we go to correlation and select bivariate. Okay, we click on this, and here it comes the variables. Sometimes we have more than 2 columns. We have education, like earning, like years of and gender, or whatever. So currently in this example, we only have education and earning. So we need to put the variable to be correlated here in this variable. So I will select education. and click here. Clicked here. Education comes here and earning. So the two variables come here. Okay, I don't want to mess with any of these because they need to be calculated as person or R. It's already there, and to tell it already there. So no need to mess with any of these options. So you just straight away click on OK. Once you clicked on OK, here it comes. The Pearson correlation, it's 0.913. So it's too high. It's almost perfect. So as you can see here, the education to earning and the earning to education is 0.913. And double asterisk is meaning that it's significant. Correlation is significant at the level of 0.01. Okay, 0.01. As you can see here, n is equal to 20. So the SPSS software is automatically calculate the R or Pearson correlation, which is the R is 0.913. Okay, I will do it again. I will do it again. So here, after you put all of your data, you have education and earning. You just click on analysis, and from the analysis, select correlate, and then you have option of correlate. You just select the second one, which is bivariate. Click on the bivariate, and you need to select the variable. It's already there. So after you select the variables from this box to this box, we have two variables. Okay, here you have two variables, and make sure this one is clicked, which is the Pearson, and click OK. Once you click to OK, it comes the correlation. So it comes the correlation and the R value. And also it show you the significant and the N and so. So with this simple step, you can calculate the correlation using SPSS. In your free time, you can just manipulate with these data and see how the correlation will change once you select or once you change these values. If actually, zero point 0.9 is a very high positive correlation. You can also do the other way around. You can start with the high income here, with the high earning, and decrease it so that the correlation will change from positive to negative. Will change to positive to negative. Okay. So does anyone got any question with the correlation before we go to the regression? Any question with the correlation? Okay. Okay, so I will give you the chance to ask question at the end of this session. Also after the test on Monday. So anyone got any problem with the SPSS can see me on Monday, because the assignment will be same today. It will be next Thursday. Next Thursday in the class hall. So all of you should bring their laptops, and we will do the assignment immediately during the class on Thursday, next Thursday. Okay, since no questions, so I will straight away go to regression. Okay, for the regression, we need to calculate the R and R square and see the significant, and also we need to measure how much the income increase with the increasing year. For example, yes, the assignment will be on e-learning, yes. So, but I will present the data during the class, and everyone will be asked to open his or her laptop and calculate the regression and answer the question and upload on e-learning. This will be on Thursday, next Thursday. Okay, so for the regression, as I told you, we need to use the regression option to calculate how much the income increase with increasing 1 year. For example, from 6 year to 7 year, how much the increase? We know that for this particular 6 to 7, we can just calculate it like 1,000, but the average, we need to calculate the average education and the average income. And so So you will see this on the regression analysis, as I told you last week, by seeing the B value. Okay. Anyway, in order to calculate the regression, we just need to click on analysis. Instead of correlate, we have here regression. Since we only talk the linear regression, so you just click on linear. Once you click on the linear, so we have here dependent and independent. It's very important. So the education and earning, which one is depending on which one? For sure, the independent is the education. So education here will be independent. Okay, earning dependent on the education. So the earning will be up and the education will be down. Okay. Once I select which one dependent and which one is the independent, we have here one option called statistic. So we click on statistic. Yes, we need to R square change and we need descriptive. So you can select these two. Residuals, we don't want to mess with the residuals because we didn't study the residuals and the data about the residuals. So I will just select continue. Also, we have here plots. If you want to see the plots or the scatter plot or the graph, instead of going to graphs and see the scatter plot, you have the option here to do all in one. So the dependent, you just select the dependent on the Y and you select the red on the X. Okay, and then continue. Here in the regression, we can calculate all of the previous. You can calculate, or you can use the regression option to draw the scatter plot, the one that I just choose here, and also the statistic to calculate the relation or the R and also the regression. Okay, after you select the plot, you just click on OK. And here you have a lot of data, a lot of results. As you can see here, we have the mean and standard deviation of each earning and education. So the mean or the average of earning, here we have 4,280.05. With the standard deviation, too high standard deviation, yes, because the difference between the income or the earning is too high. That's explain the high standard deviation. The N is 20, same N. Education, the average education is 8.6 years because we have 16 and some years duplicated. Some years we like repeat the years 2 times, but anyway, you have the option or you have the results of the mean of each column and you have the standard deviation. Okay, now, the next one, we have the correlation. As you can see here, the correlation is 0.913. 0.913, which is closely similar to the previous correlation. So meaning that you can calculate the correlation from the regression. So no need to go for the correlation itself. Okay, so here we have the correlation 0.93 for the education with the significance, which is like greater than 0.01, which is significant. The N for earning and education, both of them 20. Okay. Okay, one more thing. We have here the model summary. We have the R, which is the Pearson 0.913, similar to the above one. We have the R square, which is coefficient of determination. Coefficient of determination is 0.833, and we have adjusted R square. The adjusted R square, SPSS is got the smart tool to adjust the correlation. If you want to calculate the R square, this is the value. But SPSS calculate the adjusted R square, which is always smaller than the R square itself. We know that it's not big difference, or there is no big difference between the R square and the adjusted R square. And we have here the standard deviation of estimation. And so this is not, we are not going to talk about these. Also, it calculates the ANOVA and the significance. So I'm not going to talk about the ANOVA, because I believe Dr. Susanna already explained everything about ANOVA. Okay, the most important in this part is the coefficient. The coefficient we have here, unstandardized coefficient, which is B. Okay, as you can see here, not recording RN. Okay, we have one question from the chat box. Doctor, not recording RN. What's RN?
RN means Ringgit Malaysia.
Oh, okay. Ringgit, RN, not RM. I didn't understand right now. Actually, I didn't understand the question. Not recording RN?
I mean
Right
the
now.
question, maybe think you are not recording this session?
No, no. No, I'm not recording this session. Okay, but I will repeat the regression again. I will repeat in a fast, like in 2 minutes or 3 minutes again. So that I give you all the chance. Maybe you can like snap video or like learn again how to calculate the regression. So for now, I'm just explaining in details. So after this, I will just back in a fast track, like in 2 minutes, so that all of you may record a video or like pay extra attention how to calculate. Anyway. So for the coefficients, this is very important, the B. As you can see here, education is 483.45. So with each year, with increasing year of education, this is the excess. So meaning that from year 1 to year 2, so after, if I, for example, I added 1 year of education, the extra earning will be 483.45. So this is the extra education. Like with extra, with each year of education, this is what we are earning. This is what we are earning. Okay, so still we have here standardized coefficient. This is the R, the correlation, and we have the T value. We have the T value, which is 9.4. For sure, it's greater than the T value in the tables. If you go to the tables, this is the T, huh? This is the T value. If you go to the tables, it will be greater than the T value, meaning that it's a significant under the 0.05 and also significant under the 0.001. So it's a very high. Why? Because the correlation is too high. The correlation is already like 913 or 0.913. So that's why the T test or the T value are also very high. Okay. So now we know with each year of education how much the increasing income, and also we know the value of T, and the significant. Okay, now the scatter plot, the graph. You go down and you will see the scatter plot. Doctor, which one is the critical value? Okay, the critical value is the T value, this one, 9.4. So if you go to the table, you will find the constant or the value in the table is a way lesser than 9. So this is the critical value or the calculated T value, this one. For the other one, you need to refer. Yeah, you need to refer to the table so that you determine the degree of freedom and also determine the significant. If you want to use like 0.005 or 0.05 and so you need to determine at which level of significance you are or you want to calculate. But anyway, SPSS give you the exact T value. This is the exact T value, 9.49. Okay. So for the scatter plot, this is a similar scatter plot to the one that we saw earlier. So at the beginning of this session, I directly calculate the scatter plot using the graph option. But now, using the regression also, we can calculate the scatter plot. Okay, so now I will close this window. I will close, by the way, in the assignment, you just control B and you can save the PDF with your name before you submit to e-learning. So you should be able to save this window with all of these results, save as PDF and upload on e-learning. Okay, so for now, I will close this window and we will start over again. Okay, so if you want to calculate or if you want to draw the graph from this data, so I will assume that all of you know how to write this data in the SPSS. So if you want to like very quick draw the scatter plot, you just go to graphs and the very down one, scatter plot, scatter dot or scatter plot, click on it, choose or select symbol scatter and define. Okay, now the Y is earning, X education. You can change it by click on each. You can change it. So for the X, for example, if you want this or this, you can just click and put it here. Okay, but the true one is the X supposed to be or should be the education and the Y earning, and then you just put okay. And here is the scatter plot. This is the graph. Okay, if you want to save, Control B and save. This is the first one. Okay, and we close the first one. The second one is the correlation. If you want to calculate only the correlation, you just go to analysis, correlate, bivariate, correlate, and you select the variables. It's already there. If they are not there, you just select on it and put it like this. Okay, don't mess with any of these and you just select okay, and here it comes the correlation. Pearson correlation is 0.913. Double dot is a significant, but the significant level here is 0.01, which is more accurate than the 0.05, the one that we calculate from the t-test. Also, we can calculate from the t-test this 0.01. But anyway, SPSS is assuming that the very accurate level of significance. Okay, so it's very simple. As I said, if you want to save this window, Control B and save as PDF. Okay, so here is how you calculate the correlation. I will close this window and go to the final one, is the regression. Select analysis and then regression, linear regression. If you want to increase more data, as I said, here the dependent is earning and the independent is education. So you can change these if they are not correct. And then you just go to statistic and put R squared, change and descriptive and press continue. Okay, if you want the plot, if you want the scatter plot, you just click on plot and you select the dependent Y and the X and put continue. Okay, and then press OK. Once you press OK, it will give you a very detailed window with the mean, standard deviation, the correlation, and the value of correlation. Scroll down, you can see the R and the coefficient of determination, or R square, adjusted R square, and all of the data. If you want to know with each education how much the increasing income, you can see the B in the coefficient window. This is the most important part. It's like instead of calculating the A and B and then put the model or the regression model, SPSS can do all of this. So meaning that no need to calculate the B, no need to calculate the A, no need to calculate the regression. So it can give you the prediction after with each year of education how much they earning. Okay, and also it can easily give you the t-test, so you can use the SPSS for all of these. So nowadays no one is calculating or like manually calculating the t-test or the B or the regression or the correlation. So we have softwares can do all of this, but in the test or the final exam or whatever, you're gonna have to learn the principle of all these. My own opinion is not like I don't believe in the principle, since we have software can do all of these. So why the hell you want to like create a very complex tables and calculate the R and calculate the B, and so since we have software can do all of these. But anyway, we have to follow whatever like whatever course outcomes. Okay, scroll more down, you can see the chart, you can see the scatter plot, the dependent value for the earning and education is like this. Okay, so again I will do it last time again. So for the regression analysis, regression, linear regression, and then you just select statistic, you select the first three only, and then continue. For the plot, you just put the y dependent and the x independent and press continue and OK. And this window will come with all the scatter plot, with all the B and R, and with all these data. If you want to save, you just Control B and save as PDF with your name or with any names. Okay, so any question? Any question? Okay. Doctor, can you repeat how to save PDF slowly? Okay. Okay. To save as PDF, okay, I will see the chat box later. Okay, again, analysis, regression. Okay, I will show you how to save as PDF, regression, linear regression, and then, okay, so we have these results. You just press Ctrl or Control and B as you want to print this window. Okay, once you have this, Control B, no, not this B, the other B pin. Okay, so Control or Ctrl and P. Okay, okay, yes, this P, yeah. Okay, Ctrl and P, and then you just click OK. Once this window come to you, you just click OK. Okay, and then you will be asked to save print option. So decide where you want to save. File name, you just put any file name. For example, Yahya1 or like Lee or like Afif or any name, and you just save. Okay, and you just save the file already saved. So again, Control P. Okay, determine where you want to save in the desktop or wherever. You just write the name that you want to save, and then click save. Okay, how to save slowly. Okay, Control P, yeah, control the other Control P. Okay, again, any question? Okay, so for those who are away from their laptops or using phone currently, so you may try to use SPSS later. If you face any problem, you can see me either tomorrow or Monday after the test or any time, or you can just write to me or bring your laptops. I will show you exactly how to calculate the correlation and regression and how to save the file. So please don't miss the assignment. It's a 10 marks. So everyone should get these 10 marks because it's all about like submitting a file or two files or whatever, like, but it's very easy. So please don't miss this chance. Okay. So now I will close the sharing and share the attendance. So please scan the attendance. Please sign your attendance, and if anyone got question, he can stay in the meeting. If you don't have any question, you can just, or you are free to leave the meeting. That's all for today. As I told, it's just a quick session and straightforward.
So, Dr. Isan,
Yes.
did you set the notes for the SPSS? How to operate the SPSS?
Sorry again.
Do you, do you have the notes to how to operate the SPSS on this chapter? You said in the
No.
e-learn or not? Oh,
No. Since this is a lab session, so there is no notes for the operating or calculating the SPSS. So as I told you, like you may practice yourself. If you face any problem, you can just see me anytime or after the test Monday. So I will show you. It's just a straightforward and easy. So that's why I didn't create a notes or screenshots to operate the SPSS. I mean, like
okay.
nowadays, yeah, nowadays everyone is like familiar with these softwares. Like it's similar to Facebook or Instagram, so it's just a straightforward.